In this lesson, we're going to look at compound inequalities and how to write their solutions in interval notation. Compound inequalities are expressions with two or more inequalities. So it's what we've kind of been doing, it's just now there's two and one. And they're joined together with either and or. So you guys could have two inequalities such as x is greater than -2 and x is less than 3. That would be an and inequality. Another example would be x is less than -2 or x is greater than 3. That would be an example of an or. An and is when the solutions to both those inequalities overlap, whereas an or compound inequality, their solutions are sort of separate. We solve them together in the same problem, but their solutions never overlap. So for and inequalities, when two inequalities are joined with an and, they're written usually together as one. So like in our example, x is greater than -2 and x is less than 3. We usually just write that together as x is greater than -2 and less than 3. So x is in the middle or in between them. So the solution to these are always the intersection of each individual inequality. So to find the intersection, determine where you would shade both graphs of the sentence or the compound inequality, and then on the number line, it's really just the middle. So x is greater than -2 and x is less than 3 on the number line, it would really be to the left of 3 to the right of 2, but it's really just that middle section. That's the solution to both, so that's what we want to include. So and is the middle or the intersection or the inside. So for or inequalities, it's the solution of each individual inequality in the sentence. So for an or inequality, you solve the two inequalities separately, and then you just combine their solutions on the same number line. So for this case, you guys would do the outside. If something is less than -2, that's to the left, but greater than 3, that would be to the right. So or is out, and is in. So when we do these interval notation, that's just a different way of writing the solution. So if you look here, it says the following are 3 ways to express all real numbers greater than or equal to a and less than b. So x is just some number, and a and b are like the solution restrictions. So greater than or equal to a, that's this part here, and less than b, that's this part here. So because it's an and, we know it's going to be in the middle of them. So this part is the part you guys already know how to do. The inequality is what we've been doing. And you guys know how to do the number line. So x is greater than or equal to a would be closed, just less than b would be an open dot. So you guys know how to do the number line also. So the only thing that's really new is this interval notation. So if you guys look down here, if the inequality is not equal to, so it's just less than or just greater than, you guys use parentheses. It's saying it's coming up to that value but not including it. If it's greater than or equal to or less than or equal to, it has that equal to line, we use brackets. So in this case, brackets would also go, if you have a number line, go with a closed dot, parentheses, go with an open dot. So if you look, some of you guys might be able to pull it from the inequality better, some of you might be able to pull it from the number line better. But because a is the equal to and the closed dot, a gets the bracket and b gets the parenthesis. And that's how you write interval notation. It's saying from a to b. A is included, b is not. So let's do an example with you guys. Let's do B and C. So x is less than or equal to 5. So hopefully the inequality shouldn't be too bad. Less than or equal to 5. You guys have done that before. And I think it's actually easier to go from the number line to the interval. So I'm going to skip over to the graph. And do the graph, then the interval. So less than or equal to 5. So I'm just going to put my 5 on the number line. No need to put 16 numbers on there. It's going to be closed and to the left. So if you don't have like a section, it's not from this number to this number. If it's not a compound inequality, we can still write the solution in interval notation. Since it doesn't have a starting number, you still want to go from left to right. However, since the furthest left our graph is really going is to negative infinity, that's where our interval technically starts. So negative infinity, and it's stopping at 5. That's our interval. At 5, are we including it or not including it? We are including it. So that's all you would have to do. And actually, let's do D. X is less than negative 1, or x is greater than or equal to 5. So x is less than negative 1, or greater than or equal to 5. So, or, this is an or. So when you have an or, you actually just write them, I just kind of ran out of room, as two separate things. It's this inequality or this inequality. So we do know that for ors, when you graph them, they go out. So negative 1, positive 5, it's less than negative 1, greater than or equal to 5. So closed and to the right. Ors go out, ands go in. So the only thing here is that because there's a gap in our solution, this is a gap. We don't want to include those number values between negative 1 and 5. So looking at our graph, we can say that this solution is going to come from negative infinity to negative 1, but we're not including it. And then what you guys do is put a U to show a gap. And then where does the solution start again? For this compound inequality at 5, and we're including it. So you have an example up above of an and inequality, and I just did 2 more with you guys as an example. So you guys try filling in the rest of this chart and trying to do the inequality and interval notations based off the number lines they gave you in those problems below there. And just for future reference, guys, just remember infinity, negative or positive, infinities will never have a bracket because we can never reach it. So infinities will always have parentheses. And I don't want you guys to think that when you have a U, you write them on top of each other. It just kind of ran out of space. You would technically write this horizontally together, it's just that I kind of ran out of room. So let me sort of squeeze that in. There we go. All right, give the last ones remaining a try.